Hi everybody, I'm Professor Rad, and today we're going to talk about dividing fractions by using the prime factorization technique. So I'm just going to review the steps that we mentioned in the previous video. In order to divide fractions, you've got basically two steps. The first one is to rewrite division as multiplication by the reciprocal of the divisor, or you can use the phrase keep, change, flip to rewrite. And then you follow the steps for multiplication. And just a reminder, this first step where we change division into multiplication is similar to when we had our positive and negative numbers and we changed subtraction into addition of the additive inverse. So when we were subtracting numbers, you could keep the first number, change subtraction to addition, and then change the sign of the second number so that you were adding by its additive inverse. For division, the reason this works is because we're rewriting division as multiplication of the number's multiplicative inverse. So the reciprocal and multiplicative inverse are the same thing. So it's the same concept as when we rewrote subtraction as addition. In the last video, when we carried out the steps for multiplication, we did the multiply across method and then simplify. In this video, we're going to use the prime factorization technique. So we're going to be working through the same problems, just in a different way. And ultimately, you're going to be able to decide whichever technique you prefer. All right, so let's go ahead and work through this first example. So we have 3/5 divided by 9/10. Now, in order to use the prime factorization technique, actually, before I jump into that, I don't want to get ahead of myself. I want to rewrite this as multiplication. So let's go ahead and do that first. So we're going to keep the first fraction, change divide times, and we're going to find the multiplicative inverse of 9/10. In other words, we find the reciprocal. So the 10, which was on bottom, now goes on top, and the 9 that was on top now goes on the bottom. Okay. Now that we have that taken care of, we're going to find the prime factorization of each of the four numbers, each of the numerators and each of the denominators. The good news is these numbers are fairly small, so the prime factorization is really easy, especially for the 3 and the 5. 3 and 5 are each prime, so those aren't going to change. For 10, if I wanted to make a factor tree, it would just break down into 2 and 5. And both of those numbers are prime. So 10 is going to become 2 times 5. And for 9, that's going to split into 3 times 3. And 3 is prime. So we have our 3 times 3. Okay. Now we get to play the fun game of canceling common factors. And just a reminder, it doesn't matter which fraction the factors are in when we go to cancel. What does matter is we want to cancel out a value from the top with a value in the bottom. So for example, this 3 can cancel out with one of these, but these two 3's can't cancel with each other because they're on the same side. They're both on the denominator. So this numerator factor of 3 will cancel with one of the denominator factors of 3. And then also these factors of 5's are going to cancel out. So that's going to give us 2/3 in the end. Okay, and sorry to shake. I was just checking my work from before, and my work from before, we also got 2/3. So we're good. Next, let's try 7/12 divided by 28. So first we want to rewrite this division as multiplication. In order to do that, we're going to take this 28 and put it over a 1 so it is also in fraction format. Remember, you can take any whole number and put it over 1 because anything divided by 1 is itself. And now we can keep the first fraction, change division into multiplication of the reciprocal. So 28 over 1 is going to become 1 over 28. Okay. Next, to use the prime factorization technique, we're going to find the prime factorization of all the numbers. A 7 is prime and 1 is just 1. It's neither prime nor composite. So those two we don't have to do anything for. But the 12 and the 28 we do have to break down. So 12 is going to break into, let's do 2 times 6. And 6 breaks into 2 times 3. We also have 28. That's going to split into 4 times 7. And 4 splits into 2 times 2. Just a reminder that there are multiple ways that you can create a factor tree. So for example, if you split 28 into 2 times 14 to begin with, for example, that would also have been an okay way to start. Or for instance, you could have started 12 as 4 times 3. That's okay too. Ultimately, in the end, your prime factors should be the same as my prime factors. So I'm going to rewrite the 12 as 2 times 2 times 3. And I'm going to rewrite the 28 as 2 times 2 times 7. Okay. Canceling time. So the 1 up top is really a placeholder. And the only other factor that we have up here is a 7. And fortunately, there's a 7 in the denominator as well. So those 7s are going to cancel out. That leaves us a 1 in the numerator and a bunch of nonsense in the bottom. So we have 2 times 2, which is 4, times 3 is 12. And then over here we have a 2 times 2, which is 4. So we're going to get 12 times 4, which is 48. So we get 1 over 48. All right, and checking my work from last time as well, that's what we got last time when we solved this question too. All right, let's go ahead and look at some fractions that have some bigger numbers. All right, so for part C here, we've got 25 over 16 divided by a negative 35 over 36. Oh, so we know the drill now. We're going to keep, change, flip. We're going to multiply by the reciprocal. Now, when I write the reciprocal of negative 35 over 36, it doesn't matter if I keep the negative in the top or move it to the bottom, or I could even throw it out front if I wanted to. Personally, I just like to keep it with whichever number it was with, just to, avoid writing it twice or forgetting to write it or something like that. Now that we've changed from division into multiplication by the reciprocal, we can go ahead and find the prime factorization of each of these numbers. So I'm going to pause and go ahead and work through that. You can pause as well. And then when we're done, let's compare our answers. Okay, so I went ahead and made my factor trees. For 25, in the end, I got 5 times 5. For 36, in the end, I had 2 2s and 2 3s. So your tree for 36 might look a little different from mine, but if in the end you also got 2 2s and 2 3s, you're good to go. For 16, I got in the end 4 2s, so 2 times 2 times 2 times 2. And for 35, I got 5 times 7. Now, when I'm making my factor tree, I'm just treating it as positive. Ultimately, that negative, I'm just going to bear that in mind at the very end. So I'm going to rewrite 25 as 5 times 5. And 16, that was the denominator, I'm going to rewrite as 2 times 2 times 2 times 2. $36 is 2 times 3 times 2 times 3, or any order, it doesn't matter. And then here's where I'm going to remember, I'm going to bring down that negative. And I have 5 times 7. So you know what, to help me out in this situation, I'm going to think of that negative as a negative 1 times the 5 times the 7. That way that -1 is going to help me remember that my answer will have a negative involved in the end. Okay, time for my favorite part, which is the canceling. So I notice I've got a 5 in the top that will cancel with a 5 in a bottom. And then I've got a bunch of 2's. So a 2 from the top and a 2 from the bottom, a 2 from the top and a 2 from the bottom. Then all I have left on the top, I've got a 5 and 2 3's. And in the bottom, I have 2 2's, this -1, and the 7. Okay, so 3 times 3 is 9, and 9 times 5 is 45. 2 times 2 is 4. 4 times 7 is 28. And when I multiply that by a -1, I get a negative in the denominator. So it looks like in the end, we get a 45 over -28. Let me compare this to what we got before. See if I can find the right page off screen here. Yes, we also got 45 and -28 when we worked through this using the other method. So we are good to go. You can also use your calculator to check this answer if you wish. Right, and we have one last problem. This one we're going to use 3 fractions. We've got 2/3 times 10/12 divided by 25/36. So when you have both multiplying and dividing, you can change that division component into multiplication right away, and then you can just multiply all the fractions at once. If you have things other than just multiplying and dividing, then you might want to take it a single step at a time. But if it's just these 2 operations, you can go ahead and change them all into multiplying. So I'm going to keep the first 2 fractions because these are what are being multiplied. And then I'm going to change the fraction after the division sign. So we change divide to times, and 25 over 36 becomes 36 over 25. So whatever we divided by, we're going to multiply by its reciprocal. Now, in the last problem, we made a factor tree for 25, and we made a factor tree for 36. And those are 2 of our numbers here, 25 and 36. And in an earlier problem, we made a factor tree for 12 as well. 2 and 3 are prime, so 10 is really the only one we have to make a factor tree for. But just for practice, I'm going to go ahead and make factor trees for all the numbers. If you want to practice, you can do that as well. And I'm going to work these out in real time this time. I'm just kind of talk through my work. So for 2/3, 2 and 3 are both prime, so I'm going to keep that as 2/3. 10 I know is the same as 2 times 5, and they're both prime. So I don't have to make a factor tree to find that prime factorization. I can just write it as 2 times 5. So if you feel comfortable doing that, feel free to do that. But if one of your numbers has more than just 2 factors that are prime, then you might want to make a tree. For example, if I think about 12, I might want to break that into 3 times 4. But 4 is not prime, so probably safer to make a tree for that one. So I know 12 is 3 times 4, and then 4 we can split up into 2 times 2. So instead of 12, I'm going to write 3 times 2 times 2. Next, for 36, I'm going to split that one up into 2 times 18. And 18 is going to split up into 2 times 9. And 9 splits up into 3 times 3. Again, you can split it up differently if you like. This is just how I felt like splitting it up this time. So I'm going to have 2 times 2 times 3 times 3. And I'm going to draw a little line over here so I can keep my main problem separate from my scrap paper. And then we have 25. And 25 is the same as 5 times 5. So I didn't really have to make a tree for that one because it just has 2 prime factors. Whew, okay. I don't know, you might not like factor trees, but honestly I find them kind of like soothing because it's just like you're breaking it into smaller and smaller pieces. So maybe you feel that way, maybe you don't. If you like this method, then you might feel that way too, or maybe I'm just weird, who knows? So now we're gonna go ahead and cancel common factors. So anything in the top, cancel with anything in the bottom. So I see a bunch of 2's. So for example, this 2 can cancel with this 2. Doesn't matter that they're in the same fraction this time, as long as it's one from the top and one from the bottom. And then I'm going to cancel this first 2 with this other 2 in that second fraction. I could have used one of these 2's and that one would have stayed. It ultimately doesn't matter. Then I have a 5 that's going to cancel out. Oh, cool. And it looks like both of these 3's are going to cancel out as well. So in the end, we have 2 times 2 in the top, which is 4, and just a lonely 5 in the bottom. So we get 4/5. And if I compare that against my work from before, that's also what we got last time. All right. So now I have some problems for you to try using this technique. And again, these are the same now you try problems as we had with the other technique. This is just to give you a chance to practice alternate methods and see which one you like the best. In the next video, we're going to move on into the next chapter where we start to compare fractions and decimals to each other. So I'm looking forward to seeing you then. In the meantime, have a great day.